Hi class, in the last video we were using the Pythagorean theorem, a squared plus b squared equals c squared, to find missing sides of right triangles. In this lesson, we're going to be finding the area of parallelograms and triangles. But first, just talking about the basic concept of multiplication and area. So here we have a dozen eggs. We have 2 rows of 6 eggs in each row, so the total number of eggs that we have is 12 because 2 times 6 is 12. So multiplying can be represented by the area of a rectangle is the main idea. That area of a rectangle is equal to the length times the width, or the base times the height, where these base and height have to be perpendicular or make this right angle. So that's the main concept that's happening here. That the area of a rectangle is always the base times the height. So all other areas can be thought of in terms of rectangles. In this problem, we're given a parallelogram. A parallelogram is a quadrilateral. It has 4 sides where opposite sides are parallel. We can mark this on our diagram as this side and this side are parallel. Since they're parallel, I put those arrows there. And these 2 opposite sides are parallel. So I mark that they both have 2 marks to say that they're both parallel to each other. Okay, so since this is a parallelogram, the main idea is that we could think of this in terms of a rectangle. If we were to cut off this triangle right here and then paste it over here, then it would fit exactly right there. If we were to do that, then we would have this rectangle here with dimensions of 5 and 9. So the area of that piece would be base times height, or 5 times 9, which is 45 square units. So the area of a parallelogram is still the base times the height. The key idea is the base and the height have to be perpendicular right here. They have to make that right angle. In this problem, we have 2 dimensions, this 3 and this 14, and they are perpendicular because they make that right angle. So since they're perpendicular, they are the base and the height. So the area of this parallelogram is 14 times 3. So multiplying those together, we'll get 42 square units, or in this case, square feet. Given that this figure is a parallelogram, we're looking to find the area of it. The key is to find the 2 dimensions which are perpendicular. So this 8 is perpendicular with this 10 because of the right angle. Therefore, this 9 right there is extra information that we don't need. So we're only using the 8 and the 10, the base and the height, which are perpendicular. That's the key to doing these problems. So the area is 8 times 10, base times height, and that's 80 square inches. Given that this is a parallelogram, we want to find the area of this, the base and the height. We want to find the perpendicular dimensions. A hint on this one is that since this length is 8, then this length must also be 8. Okay? So given that now, go ahead and find the area of the parallelogram. Given this parallelogram, we're looking to find the area. This might look confusing at first because this 4.8 inches is outside the parallelogram. But that's the same length as this line that would be right here. That's also 4.8. So that would be the height. the base would be this 2.5 because that's going to make the right angle. Okay, so the area of the parallelogram, we're going to ignore the 5.2 because that does not make a right angle. That's not perpendicular. So it's 2.5 multiplied by 4.8, and multiplying those together, it equals 12. So 12 square inches. So inches squared represents the area. In this problem, we're looking to find the area of the triangle. Okay, so the key to these problems is to just think of it in terms of rectangles. So if I were to draw in a rectangle here, then we can see that the triangle that we have in blue is exactly half of the whole red rectangle, because it mirrors this part here. Those are mirrors, and these parts here are also. So the area of a rectangle is simply 1/2 the area of the rectangle. The whole rectangle would be 11 by 3. So the triangle is going to be, its area is 1/2 of the rectangle, the base times the height. So finding the area of the triangle, 1/2 times 3 times 11, and that gives us 16.5 square inches. In this problem, we're finding the area of a triangle, so that's 1/2 base times height. So go ahead and figure out this problem. In this problem, area of a triangle is 1/2 the base times the height. Okay, but we have more information than we need. So the base and the height have to be perpendicular. Here's the base of the triangle, the bottom of the triangle. So the base would be the 5 plus the 8. So that whole distance is 5 plus 8, which is 13. So the base of the triangle is 13. The height is perpendicular, making that right angle, is 6. The rest of the problem is extra information. So finding the area of the triangle, it's 1/2. Base is 13, and height is 6. So multiplying that together, we'll get 39 square feet. In this problem, the area of the triangle is 1/2 base times height. So the key is to find what the base and the height are, where the base and the height have to make the right angle. Go ahead and figure out this problem. This triangle is obtuse. It looks a little different than the other examples. It's obtuse because it has one angle that's larger than 90 degrees. So we're finding the area of this. The area is still 1/2 the base times the height. But here the base is that 7, and the height is the 5.5. So that 2 inches is extra information. So finding the area, it's 1/2 base times height, since those two dimensions are perpendicular to each other. When we multiply that together, we'll get 19.25 square inches for our area. So in this last problem, use area equals 1/2 base times height to find the area of the triangle.